The difference in this lesson is that ax squared plus bx plus c equals 0. A is not 1, it's some other number. So we have to factor this expression that's equal to 0. Let me ask you a question. How many of you remember being taught, I'm not asking if you remember how to do it, how many of you remember your Math 10C teacher teaching you something called the method of decomposition? 2 people. Of those 2 people, how many of you remember how to do it? We've had this lively argument in the math department here, and my opinion is teaching the method of decomposition is a waste of time because nobody ever remembers how to do it. It takes way too long. It's the method that you use to factor something like this. So I'm glad to see that most of you don't even remember being taught it, and I don't think anybody remembers how it would work. Because as I said, I think it's a tremendous waste of your time. Okay? What we're going to do is use inspection. We are going to factor by inspection. This is equal to 0. I used to call this trial and error, but trial and error sounds like you're just kind of rolling the dice and guessing and seeing if it works. It's more nuanced than that. When you look at this quadratic expression, 6x squared plus 11x plus 3, if I tell you that it's factorable, and I'm going to show you a trick later on to decide if it is factorable, what this means is that this multiplied by this has to give you the 6x squared. I mean, if we go back and we look at this little illustration that we just talked about, where did the 8x squared come from? It came from the 2x times the 4x, yes? Okay, so the 2 first available positions in the factored form, this position here and this position here, have to multiply to give 6x squared. Now, I'm going to go slow here because I think this is very important. Would we ever do something like this? Those 2 things multiply to give 6x squared, don't they? But why can they not ever be the 2 that you would write there? Christy?
This 2 doesn't have an x squared, which would, that's why you would put 3x and 2x.
Right. You need an x in each one because this 11x is going to come from the product of the inner and the outer. And the product of the inner and the outer have to be x's. So we would never do that. So 3x and 2x. Now, could it be 6x and 1x? It could be. Is it? I don't know. But I'm going to try this first. Okay? Now, what about the 3? Well, that's easy. And by the way, when you do inspection, you don't worry about any negatives until later. What are the only 2 integers that multiply to give 3? Forgetting about positives or negatives, 1 and 3. Now I'm going to ask you another question here. This is a little bit of a tricky one, but if you can wrap your head around the answer to this question, it will be very helpful. If these 2 numbers have to be 3 and 1, why would I never, ever, ever put them in these positions? And some of you are multiplying it out to see if it works. That's not what I'm asking. Why should I not put a 3 in the first set of brackets?
Because you can factor 3. Because you can factor out 3 from it.
Right. If I put a 3 with the 3x, I've created a common factor of 3 that I can take out. Look at the original expression. Is there a common factor of 3? No. So I can't create common factors out of nowhere, which means that I would try this. So those 2x and 3x multiply to give the 6x squared. This 1 and the 3 multiply to give the 3. The only thing left to check is that the outer and inner are going to combine to give 11x. So remember when I asked you earlier to FOIL out this expression. what you need to do is FOIL out what you think the answer is to see if you get what you're supposed to get. And I would say to you that I don't think you really need to do it on paper. How many of you see that you will get 11x? Your outer is going to be 9x. Your inner is going to be 2x. Oh, okay, so that's 11x. In other words, we've come to the conclusion that this equation is the factored form of the original equation. And all this bit of business here that I'm going to erase, that's not our work. That's me explaining stuff to you, and that's kind of rough thoughts on paper. When I told you earlier, before we started this lesson, that factoring these things is grade 10, and it's a prerequisite for this, I would say the same thing here, except you didn't factor them this way before. You factored them with this something called the method of decomposition. Does anybody remember that phrase now, and you didn't remember it earlier when I asked? It's really obscure. Okay. So where do we go from here? We're not done. What we can do is say 3x plus 1 equals 0, or 2x plus 3 equals 0. Listen, the same thing is true. If the product of these two things is 0, then either one can be 0. Because if the first one is 0, 0 times the second one will make it equal to 0. So we solve these two. I subtract 1 from both sides here and get 3x equals negative 1. I divide both sides by 3. And I get one of the solutions is negative 1/3. Here I subtract 3 from both sides and I divide both sides by 2. And there's the other solution. And if you were to graph y equals, what's the original equation? Y equals 6x squared plus 11x plus 3, and you can feel free to do that on your own time, you would discover those are the x-intercepts. Any questions with that first example? Ultimately, everybody, the work we do today is all practice in factoring. That's it, for the most part. Let's try another one. Okay, I guess I might as well introduce you to this little trick right now. You won't understand why it works, but I would like you to write down b squared minus 4ac. And by the way, in this particular equation, a is 2, b is 11, and c is 5. Do you see where I'm pulling those numbers from, a, b, and c? Okay. I would like everybody to calculate b squared minus 4ac. You're calculating 11 squared minus 4 times 2 times 5. And it's 81. And I like, just even from where my eyes are scanning the room, I saw that many of you were just calculating it without a calculator, which you should be able to do. 81. Okay, you know what? Let's calculate b squared minus 4ac for this one. You know, a was 6, b was 11, c is 3. That would be 11 squared minus 4 times 6 times 3. Is it 1? No? What is it? 49. Whoa, I wasn't even close. 49. Okay. Ask you a question. What is the b squared minus 4ac here in A have in common with the b squared minus 4ac here in B? Ashira. They're both perfect squares. And I'm going to tell you, if that thing is a perfect square, it's factorable. Anytime b squared minus 4ac is a perfect square, it's factorable. Why do we even care about that idea, that little tool? Because sometimes things are not factorable. And if you're going to factor by inspection and it's not factorable, you're going to drive yourself nuts because you'll never get it because it's not possible. So this is what I call the factoring test. Okay, so this is factorable. So let's go ahead and let's factor this. All right, well, listen, the first two openings have to multiply to give 2x squared. There's nothing even to think about there. It's 2x and x. The last one is 1 and 5. Would you agree? So you have to ask yourself where you put the 1 and where you put the 5 so that if you expand it out, you get 11x. How many of you, by a show of hands, see immediately that putting the 5 here is moving in the right direction to get 11x? Because my outer is 2x times 5, which would be 10x. We're almost there. If I put a 1 here, there's my other x. So what I'm doing, and I don't think we do this every time on paper, is you're saying, if I do the first, I get 2x squared. And that's good because, I just want to move this down a bit. That is good because that's what we want to get, right? If I do my last, that's 1 times 5, which is 5, and that's good. I always say at this point, it's ridiculous that we're checking those two because we put the 5 and the x and the 1 and the 2x there so we would get those, right? It's the outer and inner that are important. The outer is 10x, the inner is 1x, that gives us 11x. And these are all positive. Did any of your Math 10C teachers show you how to factor these this way? So grade 10 math factoring is just a big blur to you then. Gotcha. We're not done yet. 2x plus 1 equals 0. X plus 5 equals 0. Subtract 1 from both sides, and then divide both sides by 2 here. And then here, just subtract 5 from both sides. There are our two solutions. Capiche? Is that okay? Okay. Is this factorable? Well, when I say is it factorable, I'm not saying try to factor it and see if you can do it. I'm saying what is b squared minus 4ac? This one's a little bit different because a is positive 3, b is negative 13, c is negative 10, b squared minus 4ac, when you square that negative 13, it's going to become positive. Minus 4 times a, which is 3, times c, which is negative 10. See if I can get it right this time. I believe that's going to be 289, but I would like a few people to confirm that. Negative 13 quantity squared is 169. 4 times 3 is 12, times 10 is 120, and it's minus a negative, so it's plus 120. It's 289. Is 289 a perfect square? I think it is. I think it's 17 squared, isn't it? Okay. So we've established it's factorable. We factor it. All right. Well, I know you've been away for a while, but really listen to what I'm asking. Think carefully about this. To how many of you is it obvious that there's only one option for what to do with that 3x squared? It's 3x and x. You don't have any choices. What about the 10? Remember, I'm telling you, neglect the negatives. There are only two options with the 10. Well, in terms of the numbers, you can use a 1 and a 10 or a 2 and a 5. What should you try first? 2 and 5. Always go with numbers that are closer together. Well, now, and forget about the negatives, now you have more options. You have 2 and a 5. Where do you want to put them? Well, I said 2 and 5. I don't know if this is going to be right, but I'm going to write them down in the order that I said them. Okay? So what I would do now is I would say, what's my first? Well, my first is 3x times x, which is 3x squared. And that makes me happy. That pleases me because I need 3x squared. What's my last? Well, my last is 2 times 5, which is 10. Forgetting about negatives. Don't worry about the negatives yet. What's my outer and inner? Well, my outer is the product of these two, which is 15x. My inner is the product of these two. This is I for inner, which is 2x. And the question is this: can I combine in some way these two terms to get negative 13x? Yes, if the 15x is negative. I want negative 13x out of this deal. So if this is negative, that would give us negative 13x. But now how do I make it negative? Well, I kind of reverse engineer this. Where did the 15x come from? It came from the product of 3x and 5. So let's make the 5 negative. And then you need to check everything. You need to FOIL this out and just confirm that that's going to give you 3x squared minus 13x minus 10. And I hope you would agree, we've already kind of done that. We've already confirmed that it works. But one final check isn't a bad idea. So that's it. Would you agree it's factored correctly? Okay, so now all this is just us thinking. There's lots of ways we can write down our thoughts, but we don't need to write them down. In other words, there is no work, everybody, to be shown from there to there. It's just you factor it. I don't care how you factor it, to be honest. So that means 3x plus 2 equals 0. That means x minus 5 equals 0. You solve this and get x equals 5. Another question for you. How many of you see the little equation on the left, which I should have put equals 0? That equation is going to give us x equals negative 2 over 3. Okay. Showing all the steps, though, we get this. I would say I don't really care if you decide not to write this step. I don't care. I'd rather see the equation and then the answer than seeing this middle step. All right, D, 21x squared minus 51x equals 36. As you can see, there's not a lot of examples today. What's different about this? There's a couple of things that are different. Nate? It's not equal to 0. So what do we do? Right. You have to make it equal to 0 before you factor it. Always 0 a quadratic equation. So that gives me 21x squared minus 51x minus 36. Don't forget your equal 0. There's something else that's different about this, though, too, than A, B, or C. Yeah? Right. There's a common factor here. Now, I'll tell you right now, you could factor this right away, but then one of those factors would have a common factor. And I hope you would agree, factoring it right away because these numbers are so big, you have a lot of options. But if I factor the 3 out first, I get 7x squared minus, I believe this is 17x, but perhaps somebody could double check. And minus 12. Well, there's going to be fewer options here. With the 7x squared, it's going to be 7x and x. With the 12, if I had to bet, I would say it's going to be 3 and 4. Could it be 6 and 2? Maybe. Could it be 1 and 12? Could be. Not very likely, though. So let me just factor this on my own, telling you what I'm thinking. I'm not even in teaching mode right now. I'd be looking at this going, well, geez, I need two things that multiply to give 7x squared. Yeah, 7x and x. These two numbers, I'm thinking to myself, have to multiply to give 12. Well, I would say that's probably 4 and 3. I'll put the 4 here. And right away, I'm just telling you what I'm thinking. I know that this is not going to be right, because as soon as I wrote that 4, I'm looking at my outer product being 28x. Look how far away from 17x 28x is. Okay. If I did pursue this, I would have 28x here, and I would have 3x here. Good luck combining 3x and 28x to get negative 17. It's just not going to happen. So I say, well, you know what? Let's swap these. And I think this is going to work. I'm just telling you what I'm thinking. I see the outer is 21. The inner is 4. 21 and 4 have the ability to come together as 17. Right? This is 4x. This is 21x. What do I want? I want negative 17x. Well, let's make the 21 negative, and that will give me negative 17x. How do I do that? Well, I trace things back. Where did the 21x come from? The 3 times the 7, so this has to be a negative 3. This has to be a positive. Double check, and by the way, we need to double check one other thing. When you multiply this out, do you in fact get negative 12? Because if we get positive 12, it's wrong. We get negative 12. All right, that means 7x plus 4 equals 0. It means x minus 3 equals 0. And we're basically done here. X equals negative 4 over 7. X equals positive 3. And we've come a long way now since we plug it in our calculator and look for x-intercepts.